Hello. Today, let's discuss how to fine-tune a LLM model. Okay. So for that, we choose this GPT-2 from Hugging Face, and then we take this tweet sentiment extraction, which is basically finding the sentiments of the message, whether it's a negative, positive, or neutral. Okay. So first of all, let's just load this uh, data set. Okay, from data set import load data set. So what is my data set? Go to, you can just use load function, and then what is the, copy this. Okay, copy this, load. So let's execute this. From should be S, missing S, F9. Okay, execute it. Then we load this. It's being loaded. It's loading. Okay, fine. Instead, there are two data sets. One for test, one for train. So if you want to view these data in code, you can view. Then this is ed data frame equal to pandas dot. For pandas, from pandas we use the data frame of data, and we need a training, the train. Okay, fine. So let's just put this on the top. Okay, and then let's just give add a cell for loading data set. Fine, let's just check whether this works. Load data set is not defined. We need to execute the whole thing. It's loading, and then we continue. So next, we load the model. What's done? So let's see the data frame. Yeah, you have this text level and level text. Okay, so we load the model. For this, we need the transformer. From the transformer, we use the sequential classification. Okay, since this is for sentiment analysis, then we also need the corresponding tokenizer. So let's load the model. So we give the model name as model sentiment, then we use the GPT sequence classification. From here, we load from the pre-trained model. What we're going to use is this model. Okay, inside this we use this, and then we also put the levels. Okay, so the levels may be 1 minute, control y, and we load the, this is for model, they load levels. There's something wrong here. Yeah, that's correct. Then we can execute this. This is loading mobile. Yeah, we should use this for prediction and inference. This is a downstream task. This model, you should probably train this model on downstream tasks to be able to use for prediction and inference. That's what we are going to do. And what we load the tokenizer, the same tokenizer, same. Here we don't put the labels. From pre-train, and we use the pre-train model part. This is what we're going to use, GPT-2. Then what we need to pad tokenizer with n of string id token, n of string token. Then what we need to do after the loading the tokenizer, we probably do the training and testing data set. Okay, so here we do the training data set. Before that, okay, let me see something. Before that, we need to tokenize the data set. So if you do not tokenize, you cannot load it in the model. Okay, so we need to tokenize strings. We pass all the strings, and then for tokenizer we will get this. Let me check here. We need to get only this text. Okay, then padding true, then truncation also true. Yeah, then tokenized data, the uses tokenizer, we map all the data using this tokenizer. So the batch is equal to true. Why? Batch true. And then truncation should be capital. So let's execute this. Yeah, it will take some time. Okay, it's a huge data set. In the meantime, we write the code. So train, we get this from this tokenized data. We get the training set. To train, we need to shuffle, and seed we need to give some say some random value, and then we need to get the range 100. Okay, we select some 100 data. Similarly, we do it for the test set. Okay, so this is our train set and test set. Okay, so let's execute this code. F9. Yes. Okay, then we do the next. From what do we need? We need define the training argument. Okay, so for training argument we need to import the class from the transformer, and then we need a trainer also. Trainer we'll do in the next. Training arguments. What do we need to specify? The first parameter, where the output directly, where all the, when we train, all the logs, all the training process files will be stored in this directory. So it will be in the same folder where our file is situated. Okay, then the next, per device eval, per device train batch size set to 1, per device eval batch size set to 1, and then we need a gradient accumulation step, which means that it will happen after every 4 process or 4 data being processed. The backward propagation will happen. After every fourth, the backward propagation will happen. Okay, then we need a trainer. Get a trainer from transformers. Okay, then trainer equal to trainer. For the trainer we need the model. What is the model? Model is a model sentiment which is here. Then the next, the arguments, we just define the arguments on the top here. Then what else? Training data. This test eval data. Then we need the compute matrix. Okay, which we are going to define it now. Okay, so we'll define here the compute matrix. Find compute matrix. So we use the evaluate, and from evaluate we need the accuracy, load accuracy. Then we need to define the compute function predict. So predict will itself will have logis and the level value. From there we get the predictions. We get the maximum value, that is a class, and from the class we determine and then we determine the matrix. So for matrix we need to compute the prediction from the levels. Okay, predictions from these levels. Yeah. Okay, so let's have we execute the training argument? No. So we have executed df3, so we need to execute this f9. So once we are done with this, the next step we're going to do is so we did the training model. For training it's simple, train, and then we need to evaluate. Train with evaluate, and after that we can save the file, model file. So in the saving we need to specify the part where we want to save it. Okay, so when we run this, my trainer, okay, trainer here f9, for me training is going to take a lot of time. Okay, so this is all. After you train you can just see, run once, evaluate, and then you can see you can save the file. Okay, when you save it will be in this format. So you have a model. In the model you have 2 files here, and in the tokenizer you have 4. Okay, next let's run the save model. My PC doesn't have enough memory, so it restarts the kernel every time I try to train this. Okay. So I'll just load a pre-trained one which I have saved. So here we can save the model using these files. So GPT model, the 2 files here, and another is GPT tokenizer, 4 files here. So we just copy, just cut and then put it here to file. So if you want to load it, so we can load it here, file, save. So okay, so what I can do here, we can load the model. Okay, we going to use the Python later. So what do? We from transformer, so it's the same thing, same code like this. You need the same, basically the same function. Copy this. And the same tokenizer. Yeah, same thing. So but instead of this, we don't need this one here. You can directly specify the part. So here, fine tune, then this, directly specify here. Similarly, for tokenizer, you can directly specify here. So these are the model and the corresponding tokenizer. So let's see whether it works. Yeah, then tokenizer. So here you can write model loading. Okay, next, what do we need to do? So once we have this, we can just specify, say suppose this is a input text. The movie was okay. So you need to process this input text. So this will become the input. You go to tokenizer, yes, dot encode. We use this input text, return, and SOR, go to Python tensor, return tensors, then padding, yeah, padding go to true, truncation also true. Okay, so this is the input. Yeah, before that, let's just check whether the model is loaded correctly. Dot eval F9. Yeah, you see here it has embedding 502.57.768, and you can see here this is the GP2 model block. Then the output, yeah, we have three output. It is neutral, positive, negative. So it's there, so we can process these inputs, process inputs. Okay, see whether it works. Yeah, it works. Once processed, then we have model inference. So here we do outputs equal to model, and we directly give the input. So this is the this wrong here. It's not the model sentiment. Then F9. So we have the output. It's processing output here. You may not be able to interpret what is here in this output, even if I yeah. So logis. Okay, let's extract this output. Post process outputs. So here we're going to process the outputs. So first we get what is the logics. Go to output dot. Okay. Then from that we'll find which one is having the highest probability. NumPy dot. Have we defined NumPy? No. So import NumPy is NP. Why I write this here? So NumPy arg max argument maximum. So from the logis we find which one is having the maximum value. Dimension equal to -1. We have the probability. Then once we get this probability, we can get a predicted class. .arg. No, this is wrong. This is stores. This is softmax. Logits dimension 1. Then next is stores dot argument. It's not a NumPy. It's not a NumPy. Max. From this probability we find which is the maximum. Dimension equal to -1 to I10. So we just print the predicted class. So we have the output, and let's see what is it. It's 2. Okay, 2 is the it predicts output class as 2. Okay, so this is how we can use the fine-tune model, LLM model. Okay, thank you.